random? That's who says that?
It's a Weird Al Yankovic.
All right.
Wait, was there
Swell
tech news
people.
this week?
There was. You guys want to watch Tech News?
No.
Yes.
Okay.
Yes.
All right. Did you, is this on? Good morning. We watch Tech News. Go team.
Yay.
You should have homework 3.5. Looking for homework 3.5. And today is the 4th of December.
10 days until myself and Abraham's birthday.
You say. In 10 days.
We missed
For your warm-up today, we are going to do a Martin Gardner original. Hey. Dude, Martin Gardner, he's dead, so be polite.
Yeah, God, Uncle.
Okay?
Kanye West is dead.
All right. Hey. Shut your mouth. Okay. Here's what we got. 4 letters. Slash numbers. A, B, C, and D.
Absidy.
Yeah. And then in decreasing order. So A, B, C, and D are 4 consecutive. What does consecutive mean?
Reoccurring.
In a row, like 1, 2, 3, 4. Right? Or 5, 6, 7, 8. Consecutive means in a row. Increasing. So A is the smallest, D is the biggest. D, C, B, A, same 4 numbers, now in decreasing order. And then the 4 dots represent the same 4 digits in an unknown order. Okay? So those 4 dots are the same 4 numbers as A, B, C, and D, but in mixed matched order. And then the sum of those 3 numbers, the sum of all 3, is 12,300. Question being, what number is represented by the 4 dots? What number is represented by the 4 dots? Okay, so what I would recommend you do is first just choose 4 consecutive numbers and then flip them and see if you can't figure out what the 4 dots would be so that you get the sum of 12,000. Okay? Let's they are not necessarily the numbers 1, 2, 3. Okay? Let's say you want to choose 1, 2, 3, 4 or what? Someone give me 4 consecutive numbers.
7, 8, 9, 6, 7, 8, 9.
Okay, I'm gonna do 1, 2, 3, 4. So let's say it was 1, 2, 3, and 4. Then this would be 4, 3, 2, and 1. And then there's something here. And then the sum is 12,300.
Oh.
Okay, now here's what you would do, right? I'm trying to figure out what these are.
Oh, man.
So here, if this is 4 plus 1, what does this have to be to get a 0? A 5.
Yeah.
Don't forget you would carry a 1. Right? Because if this is 10, carries a 1. And this would be 6, so this would have to be 4, and you'd carry a 1. This would be 6, right? This, or that's 6, so what does this have to be? Nope.
What?
You're adding, say so? 7, right? Because I have to get a 3, so this is 6 plus 7 is 13, carry the 1. What would this have to be?
13 is left over, so if you carry the 10 over to the next
Hold on.
column.
What would this have to be?
Okay.
6 to make 12, right? Now, the question is, this is not the answer because these are not the same 4 digits.
Oh.
No, you have to use the numbers 1, 2, 3, 4, but you have
Right.
to use them in every single one of the 4 numbers.
Yeah, so if, like this was a guess, right? This was a guess. This was the numbers 1, 2, 3, 4. This used 1, 2, 3, 4. This one's going to have to use 1, 2, 3, 4
That one used
in
4,
a
5, 6,
separate,
7.
in a different order. So that's, you'll know you're right. You'll know you're right when these four numbers are the same as these ones in a different order.
It's meant to make you confused.
Okay? So just try if you're like, just try working through another one, just a guess. Try working through it and see if you can't okay, fit it together.
You have to use it.
No, you
No.
don't have to use 1, 2, 3, 4.
Well,
You can
that
use,
just showed that
Yeah.
doesn't work.
you can use any consecutive digits. Okay? Numbers in a row.
0 through 9. Right?
I don't know. You might be able to do like 11, 12, 13, 14. I don't know. I guess digits, yeah, 0 through 9.
Digits are 0 through 9. Like on a keypad.
Okay, 0 through 9.
Yeah, I was gonna say. I'm like,
Okay. So, give that a shot. How about 3.5, please?
666. You're gonna convert into chicken? Yeah, alright.
Go to that page you had in your handy dandy notebook. Go, go, go! The page that has a table on it. Let's go, quick like bunnies.
I'm already there.
Go! Yahi, open your notebook. Well, is it open to this page? No. No. Can I see? Yes. Is it open to that page? No. Still no. Open to this page! You should have this page in your notes. Open to this page. No, I can see it if it's not there. Where's yours? You need to take a picture. There, you're filling this out. You guys on this page? Where? Kane, are you awake? Where's yours? Oh, you didn't write the wrong thing. Where's that? There we go. Okay, we talked about adding by elimination. Now we're going to talk about subtracting. Here's our example for subtracting. I have 2x plus 3y equals 7. 2x plus 6y equals 1. Now, here's the first thing I want you to notice. Yahi, no. You need to be following along. Knock it off or I'm going to lose my patience. Write this down. Okay, first thing I want to look at. Lorenzo, you can tell me then. I think it's so funny. So funny for you today. Go ahead, Lorenzo, tell me. What's the difference between these two equations? I'm not asking you. How do you know that? Yeah, but you, like you, how do you know that? If I didn't have the titles, would you know that? Huh? Yeah, maybe pay attention so that you know it. Maybe. Why? What's the difference here? You're right, sure. It says subtracting. Yeah, we're going to be subtracting. Why? Anthony. Okay, over here, one was positive, one was negative. What else was special about the y's, though? They're the same what?
Same.
Yeah, that's called a coefficient, by the way. The number in front of a letter is called a coefficient. These ones were the same. It was positive 4, negative 4, and the whole goal here was that I eliminated one of them, right? When we added those equations together, the y's completely disappeared, right? Completely disappeared, and that was the entire point of the process. Okay, here, if I added these together, let's suppose I tried it. I saw it and I was like, oh, I know I can add my equations together. And I added these together, and I got 4x plus 9y equals 8. Did either of my variables get eliminated? No, right? That is not going to help me. I have done nothing to ease the problem, okay? But if we subtract, yeah, and again, Anthony changed his stance here. We're not talking about the y's canceling out this time. This time, we're talking about the x's getting eliminated, right? So here, I'm going to subtract, this is important, each piece of my equation. Okay, I'm going to subtract each piece of my equation. That's what we're going to do. So that first step is subtract, and it's important, each part of the equations. Okay, I'm going to just rewrite my equations just so we are extra super duper clear. Okay, so I have again that 2x plus 3y equals 7, 2x plus 6y equals 1, and I'm subtracting 2x minus 2x, 3y minus 6y, 7 minus 1. And if I do that, and I subtract each part, 2x minus 2x is what? 0, right? That's our thing that's getting eliminated, and that's the goal here, and that's why it's called elimination. So that's 0. 3y minus 6y, negative 3y, and 7 minus 1 is 6. So of course the second thing we get to do is now we get to solve the new equation. Yep. So our new equation was negative 3y equals 6. And it's much easier now, right? In one step, Kane, pick your head up. In one step, we went from two complicated equations to one simple equation. Okay? So, okay, so right here I divide by negative 3. Negative y equals negative 2. Yep. And just like you should be able to see on the other side of your page, if we know y, what else do we need? Okay, yeah. Plug in and solve for x. We're going to go back to our very top equation. Okay, back to 2x plus 3y equals, 7. And I'm plugging that. Where am I going to plug negative 2 in?
We're going to plug negative 2 forward.
How do I know? Abby?
Because negative 2 equals y.
Right. Because that's what it's equal to. Sometimes we get confused if I'm plugging it into x or y. If it's equal to y, plug it in for y. Okay? There's a reason this structure is here. Okay? It's not just random. So I plug negative 2 in for y, and would you guys please go ahead on your own and finish solving. Tell me what x equals. Tell me what x equals. So I get 2x equals what? 13. Yeah, Yahi? Yeah, 2x equals 13? Wait, weren't you guys arguing about it? Oh. Alright. So then what's my answer?
1x equals 6.5.
So make sure you write your answer as an ordered pair to be good practice. 6.5 negative 2. 6.5 negative 2. Okay. Now, trick with elimination is as follows. The only tricky part about elimination is deciding whether you're adding or subtracting. So, here's what I need you guys to do in your groups right now. In your groups right now, I need you to write sentences, 2 of them, for how you know whether you are going to use adding or subtracting for elimination. Alright, so you should have been on a random page, so we're going to start a new page of notes. New page of notes. A3. Systems. Quick write. Answer this question. My question, how do you know whether to add or subtract the 2 equations in elimination? How do you know whether to add or subtract? I'm going to give you 2 examples that eventually you're going to solve. If I have that's my first example. And here's my second example. So if I'm comparing these two examples, how would I know? How would I decide whether I want to add the two equations or whether I want to subtract the two equations? Okay, so the first thing I want you to do is take 2 minutes on your own to think through this question. Maybe you think through that question by starting these problems. Maybe that's how you do it. But in 2 minutes, I want you to have at least 2 sentences written down for how you know whether to add or subtract the two equations. I'm not necessarily asking you to solve this system right now. Maybe that will help you. Kane? Okay, so 2 minutes, individual time to think for a bit, think through those two things, and then we'll talk in our groups. 2 minutes. In your groups, each person is going to share their 2 sentences. Okay? Even if you have something you think is similar to someone else, you're going to share. Even if you don't know, and you're like, I don't know which one to use, that's something to share too. Okay? Each person in your group take your 15 or so seconds to share. So you guys as a group have a minute. What you guys have? Anyone feeling particularly confident? Abby, what do you got? Hold on. Listen, hey, here's the deal. Omar, Abby is saying this to you guys. Right?
Yeah, okay.
As a hint, I know the answer. Okay? So we're trying to see if we can't make some sense in our brains, right? So she's not necessarily telling me. I want you to listen to what she says and go, does that make sense? Does it not make sense? Does it fit, or can I prove her wrong? Okay, so listen to what she has to say. Abby, what do you got?
Okay, so I've only seen 2 examples of these, so I don't know if it's correct.
Yeah.
But so far the only pattern I see is that if both the y values are the same number, but one is a negative version of the number and one is a positive version of the number, you should add them. And if the y values are different numbers, you should subtract them.
Julie, did you hear what she said? Does it make sense? Does it fit these examples? How? Okay, let's hear it again then. Okay, so Jolie, this time I want you to listen to what she has to say, and see if it fits. Look at the equations, these examples, and see if Abby's saying fits the examples. Okay, go on. Abby, go on.
So the pattern I saw was that if the y values are the same number, but one is positive and one is negative, like in the adding column, you should add them. But if the y values are different, you should subtract them, just like in the
You hear what she's saying? What is she saying? The y values. Okay, so using that logic, ready, Jolie? Using that logic, if the y values are the same, I add them. If they're different, I subtract. What should I do on this example? Huh. Well, hold on. Because they're different? Okay. Do you guys agree? I see a lot of hands. We're going crazy. Kane, what? Okay, can you, Abby, respond to what Kane's saying? Because he's disagreeing.
I don't know. That's what I meant by like I've only seen 2 examples,
Yeah.
one of each kind, so it's not like I could actually make an educated guess.
No, but that's
on it.
okay, but just
What it
build.
yeah.
Because he's saying, because the only difference of what I heard is Kane is saying it's not necessarily about the y values.
Yeah.
He's saying it's about whether, if there's 2 numbers that are the same, you're talking about, Kane was saying, well, if one's positive, one's negative, I do something, and if they're the same, like both positive or both negative, I do something. Right? Yahi, you're dying. What? This one? That. So you're trying to lose one of your variables, right? Or eliminate. That's why it's called elimination. So we're trying to lose either an x or a y. Jolie, what were you thinking? Okay, so we need to know, we need to add or subtract depending on if we're eliminating an x or a y. So then let's look back at these examples I gave you. And can we know whether I should add or subtract? Like, so here, if I look at this, let's try and figure out first, do we know which variable is going to be eliminated? Looking at this, which variable, x or y, Abraham, is going to be eliminated? How do you know x? Okay, because they have the same coefficient, right? Because they're both -6, just like Abraham said. Both of the coefficients, the numbers in front, both of those are -6. Now the question is, should I add or subtract? Who says it? You said add and you said subtract, right? Okay, add or subtract? Anyone? Cool. In your team's new task. In your team's new task. Decide if we add or subtract right here. Have a reason. Add or subtract.
Well, that's what I've been doing to double check what I've got. So if you add them, they come out here. But if you subtract them, that's -6 and -6 cancel each other out. And 6y minus 3y, it becomes 3y equals 18. Divide that by 3, y equals 6, and then we're going to check.
Yes, I did. No.
Okay, who's feeling it? Add or subtract?
Subtract.
Oh my gosh, how are we supposed to say? Who feels most confident? What are you saying? You're subtract? Who says subtract? You say subtract. Who says add? Oh. Abraham, Jolie, what do you got? How can we say no, it doesn't? Or how could she, we're talking about different things. So either Jolie needs to prove us right or someone needs to prove us wrong or something. Anthony, what? Well, you're subtracting. Wait, she's talking about adding. Talk about what Abby's talking about. She said, when I add them, the x's will cancel out. Now, why are you saying no, they won't? You're saying -6 minus 6. She's talking about adding.
-6 is 0. Exactly, that's what we're saying. If you do go with adding, you end up with -6 plus 6.
Okay, hold on.
Equals 0.
If I add these, let's get the right statement going. If I add these, what am I adding? Thank you. If I add these, -6 plus -6, right? That's adding them. And it goes up -12, right? If I add these, and I need to be careful I'm adding, -6 plus another -6 would be -12x. This would be 9y, and this would be negative 6. When I added them, hey, when I added them, did I lose a variable? No. Okay. If I subtract them, negative 6 minus negative 6, right? Negative 6, big minus, little negative. I get that 0 that we're going for. Okay, so yeah, right? This one, I subtract. What do I do over here?
Add.
Let's go through that same process, shall we? Decide right here if I add or subtract. Decide in your teams. Make sure you have a good reason this time. You're saying add? Why? Hold on. What? Okay. Hold on, Lorenzo, you're back. Say it one more time for us. This is what, because, why? This one here. So wait, it's which method? Let's try it again. So it's what, because, why? Go. Say it as a nice sentence for me. It's blank because blank. We're gonna keep working on it until you get it. Hit me one more time. You're absolutely right, but right precision of language. Said. Beautifully said. Okay? Yes. This is adding, and I love the reasoning, because negative 6 plus 6 equals 0. So, hold on, because now we're going back to the future. Okay. Back to this. Still the same question that I have. How do you know whether to add or subtract? Okay? I could look at your homework. Right? How do I know whether to add or subtract? That's the thing we're looking at. So let's look at this first example of your homework. We're going to do the same process right now. I want you to decide in your tables whether you should add or subtract this one. In your tables, decide. New example. What do you got? Because why? Say that again. Okay. We need to be a little bit more specific. Because if I say it's addition because there's one negative and one positive x, be more specific. Because here's the disproof to what Hallie's saying. And Hallie, I'm just picking on you because I can. Okay? If I had this. Oh, wait. Actually, I don't even need that. Right? Hallie said because there's one negative and one positive on x. But look. There's one negative and one positive on y, too. So what is it specifically, Omar? How do I know I'm eliminating the x? You want to add to yourself? Go ahead. Cool, because it's the same number, right? Because the coefficient is the same value, right? It's 4. One's positive 4, one's negative 4. So we would add. We would absolutely add. Okay. What would I do for number 2? Why are you guys getting that so fast? Yahi? so you're talking about Yahi's saying he wants to flip the signs. Like he needs this to be a positive 9. How do I make it a positive 9? Yeah, subtracting a negative, right? Subtracting a negative. Okay, so looking at these, Hallie, can you add how you would know it was subtracting? Like using what you said last time, kind of, or no? Okay, because they're both negatives. So here's the trick. Kane, what do you got?
Okay, alright guys. They're both same number.
Okay, so, I don't know. So, here's what we need. We need a nice sentence. Okay? If the coefficients are the same, right? 4 and 4, 9 and 9, 3 and 3. If the numbers are the same, Lorenzo, Omar. If the numbers are the same, when do I add? When they're able to cancel out, or what Kane said, if one is positive and one is negative. Okay, so if, here's the deal, write this down. If the coefficients are the same, we're going to have two if statements. If the coefficients are the same, right? 3 and 3, 9 and 9, 6 and 6, 5 and 5, whatever they are. But one's positive and one's negative, what do I do?
Or vice versa.
Right? Or vice versa. What do I do if one's positive, one's negative? Not so confident? One's positive, one's negative. The coefficients are the same. Look up. Which one has one positive, one negative? Add, right? Add. If the coefficients are the same, but both positive or both negative, right? If they're both negative or both positive, what do I do? Boom. Okay. So here's actually what we're going to do. I'm going to give you guys your homework right now. But what I want you to do, what I want you to do before you do any of the problems, I want you to go through and write on the side whether you're adding or subtracting. Add or subtract. Add or subtract. Is this clear?
Yes.
Nope. Write the word add or subtract.
It's very, very clear. We even wrote it.
We have other things to do. I'm just getting started. For when we finish the first 3. If you'd like to talk about number 4, Ansel has an idea though, and he would probably help you out. I have an idea too. If you want to work on here, you may. If you'd like to work in your notebook, you may. But I want you guys in your teams right now. Did I say something weird? My bad.
You gotta be quiet. Thank you.
I want you to finish. Does everyone agree on their teams what we're adding or subtracting?
Except for 4.
Except for 4. Okay, we'll talk about 4 in about 12 minutes. It's not. That's 4 minutes per problem. It doesn't even take that long.
We already had this problem.
Cool.
We had 3.
All right. Solve 1, 2, and 3. X and Y. X and Y. Ready, set, go. 4. Here's the deal. We'll in fact do number 4 together. In your notes, please, we're going to do number 4 as an example in our notes, so when you want credit for it, you can put it on your homework. Okay, in our notes, real quick, this is the final method.
The elimination part. Wait, multiply. What?
Elimination by multiplying. Example. I know, just keep it together, team. No, sir.
My brain hurts.
Last one.
There's no such thing as division, Anthony.
What?
It's just multiplying by a fraction.
Whoa.
Somebody's highlighting
Big
the
plane there.
You can ask me how I feel about subtracting too, but we'll save that for next week. Yeah. It's really only adding and multiplying. The only two operations that matter. Cool, you're still multiplying. Yes. Did you use the word multiplying? Okay, then you're adding. What's your problem? All right. Here is the problem. Right? The problem here is that no coefficients are the same. Right? The problem no coefficients are the same. Now, I will say you could use substitution. Right? We could do a really long substitution problem, but it's not necessary. What we're going to do instead is look at how could I make the coefficients the same? Right? Looking at these, is there something I could multiply one of my equations by to make the coefficients the same?
Couldn't you multiply the bottom equation by 3? Or, I mean, negative 3? If you do
Now-
negative 3 times negative 3, it would be a plus.
Cool. We know that 3 times 3 is 9. Here's the question. Do I want to multiply by negative 3 so I have a positive 9? Or do I want to multiply by 3 so that this is a negative 9?
Oh, positive 3, yeah.
Because it'd be nicer if it's plus 9 and negative 9, right?
Yeah.
So here, we're going to use that, and we'll say, great, I'm going to multiply this bottom equation by 3. Yes. You could try a common factor. I'm not going to go that route. So our first step is we're going to multiply. Shh. Each part of the second equation by 3. Right? Each part. Hey, I don't want you talking right now. Multiply. Shh. Multiply each part by 3. So my second equation is now 3x minus 9y. Yahi, stop talking, please. He's talking about math. You're not. You're talking to Omar about something else. That's the difference. So, shh. Don't talk about that. Okay? Each part of the second equation by 3. So the second equation now looks like this, right? So that's my second equation now. My first equation is still like this. Negative 4x plus 9y equals 9. And now when I'm looking at them, should I add or subtract? What do you say, Sol? You say add? Holly, why you say add? Because 1 negative, 1 positive, the 9s are going to eliminate. So now we add. Okay? In order for you to have credit for your homework, I need to see number 4, that's this one, done with an X and a Y. I'll give you a stamp. And you should have 1, 2, and 3 finished, but I don't know your life. All right? Let me know when you're done. It needs to be done and correct. I'll stamp it. Yes. Nah. 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 Maybe, Anthony. I don't want to get into it with you right now. Bonus?